Hi everybody, and welcome to this video on finding industrial control systems with Shodan. I This is a subject that I'm very passionate about. Anything around industrial control systems and operational technology, or when we talk about ICS, OT, or control systems, I'm very passionate about. And you can see here, a couple examples of the environments that run these specialized different types of systems. So whether it's a power plant or a railroad. Like here we have light commuter rail, a subway in a city. You can see a water treatment facility or a type of refinery, or here there's an open pit mine. The idea is that all of these different environments have specialized systems or control systems that are used to make things move in the real world. So to generate power, to move a train to get people to work in the morning and get them home at the end of the day, to make sure we have clean water to drink, to make sure we have different chemicals that make our life better in every way, shape, or form, and the mines that bring us different materials. So I've actually been very fortunate to work in all of these environments except for water treatment. It's not something that I do in my day job, but definitely in refineries and power plants and commuter rail and even in open pit mining, which is really interesting. So um, why I wanted to put this video together was I think it's very important to understand that these environments are very special. They're very special in their own unique ways. And if by chance one of them gets connected to the internet by having one of its internal systems exposed, that an attacker could use to take advantage of, perhaps a vulnerability in that system, take control over that host or that asset, and then use that as a foothold on the network to then gain further control over that power plant or that subway or the water treatment facility or so on and so forth. And so when we start talking about industrial control systems, we're really talking about physical safety, making sure everybody on site is safe. And imagine, what if somebody could potentially poison the water, or we look at the safety of the environment around these facilities. We want to make sure that nothing happens to the facility to where it's going to have an impact to the environment. And then we also want to make sure those environments stay up and running. If I have a power plant, we want to make sure it's up running 24/7, 365, generating power. Right? We want to make sure the subway is up and running and so on and so forth. Because we can live without power for, let's say, half hour. And we could probably live without power for 3, 4, 5, 6 hours. But as a blackout gets extended, what if that power plant is down for 24 hours or multiple days or multiple weeks or multiple months? And you start to get the idea. So we look at when these different types of environments are impacted, right? There's a real world consequence that comes with it. And that's why, for me, that industrial control system security is important. So let's go ahead and jump into the rest of the presentation. And the idea is we're going to take a real quick look at the more common ways that attackers get into these different types of environments. And then the rest of the section, we're just going to look at how we can find these different types of systems that are connected or exposed to the internet using the Shodan search engine. So there's a couple of main different ways that attackers can get into control system environments. And one of the more common ways, like we saw in the Colonial Pipeline breach about 2 years ago now, is the attackers, which was a common ransomware group. Right? They got a employee in the back office to click on a link or open up a malicious attachment, infect their system, and then that infection probably was starting to spread into the control system network at Colonial Pipeline. I think if the only people that really know what happened are those that work at Colonial Pipeline, or if you're in the FBI or the NSA or whichever incident response team were helping the Colonial Pipeline folks recover. right? But that's a very common way for attackers to get in, is to start on the IT network and then use the connections from the IT network to move into the OT network. It's also common to see that things like malware are brought into the environment by what they call, in the ICS world, transitory cyber assets. Or really, these are USB drives and laptops. So it's a fancy way of saying, yeah, somebody can bring in a USB drive that's infected and plug it into one of your systems on the OT network, or also look at uh, bringing in a laptop. Like you have a vendor coming in to do maintenance on one of your systems. So they bring in their laptop. What if that laptop is infected, right? And then they plug that into the OT network, and then that infection is able to spread potentially. Another way to give an attacker a foothold on that network. Of course, we talk about why we're really here is control systems can actually get exposed directly to the internet, whether somebody does this on purpose, which is really concerning, or if it was by accident. But it does happen. And we can see that by using a search engine like Shodan, which again is why we're here. And there's other ways worth mentioning, like remote access, because a lot of OT environments give remote vendors access to their environment, so they don't have to come on site and work in a dangerous environment. They can do operations and maintenance, like upgrades to systems, remotely. And then we also have malicious insiders, which we can see in these specialized types of environments as well, where somebody wants to do harm to the company and maybe they sell access, or they are going to infect a system and then use that for their own nefarious purposes. So those are some of the ways that attackers, some of the more common ways attackers get into the environment. But again, we're really here to talk about when control systems get exposed directly to the internet. So we have Shodan, and if you're not familiar with Shodan, it acts as a search engine, very much like how Google's a search engine where it indexes web pages on different websites all over the internet. The idea is Shodan also scans the entire internet, but it's not looking just for web pages like Google is. It actually is looking for things that are connected to the internet, which is really what it was started as a tool by John Matherly, was starting that built Shodan to scan the entire internet to find not just computers that are connected to the internet, but interesting things that were exposed to the internet and that you could see. So that they scan the entire internet. Now, they don't scan for all 65,535 TCP ports and all 65,535 UDP ports. That would take way too long when you talk about scanning the entire internet. But they do scan the entire internet for a few dozen popular ports, right? Common ports that different systems use. And we can look at the common ports that are used by industrial control protocols as one way to find different industrial control systems that are exposed to the internet. And they are there, even though a lot of these environments don't think their systems are exposed, but they are. And so you can find Shodan at shodan.io. It's not .com. I think .com got registered by a malicious group. I'm not sure if it's still malicious or not, but if you're trying to visit shodan.com from a lot of, especially Windows systems, the Windows will actually automatically block you from going there. It'll stop you, give you one of those nice big red warning banners. So go to shodan.io and you'll get an interface that looks like this. And so you can see with Shodan, again, it's very similar to Google as far as acting like a search engine. Now, what we do with the search engine, that's a little bit different. And that's what a big part of what we're going to focus on in this video. And so you can see, and I did put together a quick start guide. If you want, you can download it from my GitHub. You can see github.com/utilsec. And in the repositories there, you can find the quick start guide for ICS OT. There's also one for general IT as well. and then a quick start guide for another similar search engine called Census. But you can see here's the one for ICS OT, and this is really what we're going to walk through during the rest of the video, and going through and looking at the different ways that we can find industrial control systems that are exposed to the internet, especially if you are doing a pen test for an organization, or what if you work on the cybersecurity team for an organization. You want to make sure that you're doing this type of reconnaissance to make sure that your client or your own company don't have exposed systems to the internet. And it works great for all types of systems, not just in control systems or operational technologies, even though that's what we're talking about here. Right, so you have the quick start guide as a little cheat sheet to help you. And if you want to go back and you don't have to listen to the video again, you can just pull out the cheat sheet and use these different search terms. And so I start looking at using Shodan. Okay, when I first really started getting into industrial control security, Shodan was one of the first places I had come across. And I was already a little bit familiar with it, doing penetration tests and OSINT, right? And doing reconnaissance on different client environments and the main company that I worked for. So I was already aware of Shodan. But if you go to the Shodan page, and you can actually get a free account. The free account is a little limited, so it does limit you to 2 pages of results. So I do have a slightly better account, I guess, one that I'm using for this, so we can see more results. But you can still use a free account and still get a lot of great use out of it. So you don't have to pay. But anyways, so if you go to the Shodan, and this is the same interface as it was 10 years ago when I started looking at it from an industrial control security perspective, where I click on the explore option, the first thing you see. And then the first thing you see from there is industrial control systems, which you can see there's a picture of a mine, right? You can see there's a mine and some other types of kind of facilities that are crammed in there. And what we're actually seeing here is they talk about, yeah, there's some terms, there's a lot of new acronyms in ICS OT to learn if you're new to that world. So things like SCADA and PLC and DCS and all things like ICS and OT could be even new terms to you. But the idea is there are different types of systems within that world. You can still think of them as computers. Engineers hate it when I say that, but they're devices with memory and processors and network connectivity. And so if they get connected to the internet with a publicly exposed IP address, or exposed somehow behind something like that, right, we can see them through Shodan. And we're not doing the scanning ourselves. Shodan is. But what we can see here on this page is they're actually showing us a number of common protocols and services that are used by industrial control systems. So the most popular control system protocol you'll see is called Modbus. And the really interesting thing with Modbus is there's old school Modbus, which was its own protocol, just like TCP/IP is its own protocol. And now there's a version of Modbus that runs on top of TCP/IP, which is where the danger is. Because if you had old Modbus that wasn't communicating over TCP/IP, someone essentially had to be local to that network, right, to be able to communicate with that device. That's just at a high level. Now, in this case, though, we see Modbus running over TCP/IP, which, of course, is the main protocol that we use on the internet. And so we can see these different types of devices. Same thing with S7, which is, you can see a Siemens, right? Siemens is one of the largest vendors in the ICS OT space, especially if you're in the Western hemisphere of the world. And so S7 is the protocol that they use. And you can see DMP3, Tridium. I don't really come across Tridium a lot, but I have BACnet, which is for building automation control systems. We can talk about Ethernet over IP, and the list goes on and on. So it's a great resource if you're just even starting to look into industrial control securities, because you can start to look at some of these different protocols and then you can go and research them. And so you can go through and look through the list of what's there, which is really what we're starting to see here. It's a great way to start learning. At least that it worked great for me. And so when we want to look at, well, how do I find these systems in Shodan? Now, if you have a paid for enterprise account, and an enterprise account now is, I think it's like $1,100 or $1,200 a month. So I don't know necessarily there's that many people that have those accounts readily available. There, you can use the option of, like what you can see here is of a tag. And so what the tag is as Shodan finds different systems, it can label them, it can tag them as different types of systems. Meaning, so what we'll do is we're just going to go ahead and jump into one of these first. So if I click on Explore Modbus, what we'll actually end up seeing is a list of all of the Modbus systems that Shodan has found exposed to the internet. And you can see there's 388,424. You can see right in the upper left-hand corner. And you can see the vast majority of those are in the United States based off of the IP address. And then you can see there's 22,000 in China, Canada, and Korea, and France, and the list goes on and on and on. And so we can look at, these are the different systems that are running or appear to be running Modbus. Now, we won't say they all are. And really what it's seeing is there's a system that has port TCP 502 open, which is the port we use by default associated with Modbus. I'm trying to find a good example in here because what I'm looking for is a system that's legitimately running Modbus, and that's exposed. And here's actually one. So this system at 192.150.249.250, right? And you can see it's located in Thailand, and you can see it's tagged as ICS. So Shodan found the system exposed to the internet. It found the Modbus port was open. It also connected to that port and tried to gain additional pieces of information, right? It tried to do some basic communication to get it to talk back, to then understand, well, what's running on that port? Is it really Modbus running on TCP 502? And in this case, it looks like it does, because we can start to see this ID, or you can see the unit ID response. So unit ID 0, unit ID 1, unit ID, and then going up all the way to 255. And so we see that there's this Modbus service that's actually running there, and that it retrieved at least a basic piece of information. And we'll see some more examples of this. But for now, I wanted to look at how we use the tag. So I can do, if I had one of those fancy paid for enterprise accounts, I could say tag : ICS, and it would show me all of the systems that Shodan has found that has been tagged as industrial control systems. Right? And there's going to be a lot more than just these 388,000. Remember, these are just those systems that appear to be running Modbus, which is a protocol and service that's associated with control systems. Right? But there's also all those other protocols and services that we started to look at, like S7 and TMP3 and BACnet. Right? So that's one way you can find things in Shodan. But again, most of us probably don't have a fancy paid for enterprise account. And that's okay, because there's some workarounds that we have. But again, it's a great way also just to learn those protocols like Modbus and start to get an idea of how it communicates. And when we look at, in this case, you can see how it updated the search in Shodan to port 502, which is what we were mentioning earlier. So that's the port that Modbus commonly runs on, TCP 502. So that's tags. So again, they're great if you have an enterprise account, but if you don't have them, that's okay, right? So we don't have to necessarily, it would be nice if we did, right? Here's an example Another Modbus system that you can see is from Schneider Electric. And it's funny because I actually recognized this one because I actually have this one set up in my homeland, which was pretty funny. So it's actually called a Modicon PLC, or Programmable Logic Controller. And this is so we can see as Shodan found the device running on TCP 502, it found the service exposed. It ran some additional communication to see if it could get the device to respond and determine, hey, is this really a PLC running Modbus or not? In this case, it looks like it really is. So it got labeled as ICS. And then we can also see the vendor, Schneider Electric, which is one of the most common vendors in the ICS world. And then you can also see the model of that PLC. So we can actually Google for that to see what it actually is. And then we can even see the version of firmware that it's running. So if there's known vulnerabilities with that firmware, we could use those potentially to exploit the system and gain a foothold on that network because that system is exposed directly to the internet. But if you're curious to see what this thing, this PLC actually looks like, this is actually it. So again, it was actually interesting when I found this one. It was one of the first results that had come up, and it was like, oh, I that looks very familiar because this is actually what it looks like sitting in my house. So, so that's what this PLC looks like. If you want to see a lot more interesting PLCs, obviously you can go Google, or if you're a big Reddit fan, you can look at the Reddit for just /PLC. And there's a lot of engineers out there that post a lot of the pictures of their PLC installs in the field, which is really I find really fascinating. So you'll have to definitely check that out if you're interested in more. But that's again the idea of the tag is that Shodan, when it finds different systems connected to the internet, it tries to enumerate them, right? It tries to do additional tests to figure out, hey, what is really there? What is, in this case, what's really sitting at 218.62.117.154? And in this case, right, it found Modbus open on TCP 502. It did the additional queries and found out it really is Modbus, and it's a Schneider Electric Modicon, and it's even running this specific version of firmware. So yeah, we're going to label it ICS. And so if you have that corporate enterprise account, you can just look up those tags. But moving on from the tags. Right. Oh, before we do that, I did want to mention there is a really interesting tag as well for honeypots. Right? So if you're not familiar with honeypots, so honeypots are systems that are set up to be hacked. The idea is that you create these systems, you expose them to the internet, or you use them internally, which they're great from an intrusion detection perspective. But the idea is you can expose them to the internet, and then you can sit and you can watch as attackers find the system and try to access it, right? They try to attack it. And then you can learn about the attacker methodology, right? You can start to see what are attackers doing when they find your system, right? And then you can start to also, especially in the industrial control world, you can start to realize, is it a generic attacker that has no idea of what they're doing with industrial control system, or is it a more advanced type of attacker? And that's typically going to be either nation state attackers or what I like to talk about is like top tier hackers, or attackers that have a sense and an understanding of control systems and how they work. And they're seeking out these systems that are directly exposed to the internet. So honeypots are really fascinating. And that could be its entire class in and of itself, right? But I love deploying them to the internet when I can from time to time, just to sit there and watch when people find them, from scanning on the internet, which is almost instantaneously these days, right? And then as they start poking and prodding to get an idea of what's actually there. Maybe it's just Shodan doing a scan and trying to figure out what's there. And then also mention that it's great from an intrusion detection perspective if you deploy them internally, because if you have somebody hit your internal honeypot, then it's what we call a very high fidelity alert, which means it's an attacker, right? If you've set it up correctly, and that the only reason somebody would hit that is if they're trying to attack your network, then it's one of those great methods you can use from an intrusion detection perspective to find an attacker on the network, right? You get a hit, boom, there's an attacker on the network, period, the end. Right? So it's a great defensive mechanism. But so that's one of the other tags that I find really fascinating that pops up from time to time. So you'll see them from time to time. So it's this idea where they fingerprinted, right? They figured out that there's the honeypot sitting there. Right, here's an example of a honeypot that you can see that's sitting in Warsaw in Poland. And it has a very distinct fingerprint. There was a lot of these in Shodan, but Shodan realized based off of this one signature, yeah, it's a fake system that was designed to be attacked and watch what the attacker does with it. Of course, Shodan's tipping off the attackers in this point, which I'm sure the advanced attackers or top tier or even probably maybe the middle tier attackers, they're already probably going to realize it's a honeypot and move on to bigger and better things. But you'll definitely see some script kiddies and new attackers, um, you know, sitting there and trying to hack away at these boxes, which always is still kind of funny to watch. So, all right. So the rest of the presentation, again, let's move past tags and enterprise accounts and what can we do with a free account or a the lower cost tier if you do want to get a paid for account so you can get more than just 2 pages of results. So one of the things we can do is we can run searches for common ICS OT terms. And you can search for ICS and OT, and they will actually return results. ICS is much more specific than OT. So, what you get with OT is you can take it or leave it. Probably it's a little bit more generic. But ICS is still a very valid string to look for. SCADA also is one of those ICS related terms. So SCADA and ICS, OT, they're basically three terms for all the same thing. But I remember Rob Lee, who's considered these days the kind of the godfather of industrial control security in the world. He taking his class at SANS. He had mentioned the only difference between SCADA and ICS-OT is SCADA is like a WAN, and ICS-OT is like a LAN. Right? So in ICS-OT, all of your systems are on the local network, whereas in SCADA, right, those devices are communicating over a WAN. So if I have a power company and let's say I'm monitoring hundreds of power stations, or let's say just dozens of power stations that are spread out across the region. Right? I have some systems that sit you can think of the main operation center, and then it goes out over some type of WAN connection to check in with the control systems, right, at those remote sites and pull that information back, what they call supervisory control and data acquisition. And so we can do that over the WAN. So that's what SCADA is. That's the difference between SCADA and ICS OT. And so when we look at running a search, right, if I go back to Shodan and just run a search for SCADA, still a little slow. Might be my internet connection today, I'm not sure. Eventually, I should have done these searches ahead of time, apparently. Drumroll please. There it goes. So we can actually, so you can see there's 1,584 systems that have SCADA in the text that's communicated back from the system, meaning when Shodan finds this system connected to the internet and it sends out those additional requests, right? It tries to talk more and interrogate essentially or enumerate the system. right? It's sending additional commands, trying to get responses back, like Nmap enumerates systems if you're familiar with Nmap. And so in this case, the idea is that some of the text came back and it had the word SCADA in it. So it doesn't necessarily mean it's a SCADA system, but it has SCADA in the information that's been returned. And so you can see, and here's a couple of honeypot tags, right? So we know those are probably systems that were created to be hacked. Now here's an interesting one. You can see at 110.93.215.54, it actually looks like it has SNMP exposed on the system, and then the name on it actually you can see is KE-DHA-SCADA. So there could be some type of SCADA system that is actually sitting there. And then they even give us this contact email address. So if we want to reach out and let them know, hey, you have a control system connected to the internet, you might not want that exposed. So that's one way you can look for these different types of systems, right? So if we look for SCADA, or again, you can do ICS. ICS actually does come up with some really interesting results. Oops. I guess it wants a credit card apparently. Interesting. Let's run that search again. There you go. So now we run ICS. And then you can see it comes back with a number of different interesting findings. Not a ton. You can see 2,800 and change. But you can see in this case, it looks like, oh, maybe there's a web page and it says Overbyte ICS TCP server. I could Google that to see, is this really some type of ICS system, or maybe it's some type of application that just happens to have the acronym ICS. Again, if we're doing the lookups by these names, right, Shodan is just looking for where it sees these acronyms returned in strings. It doesn't necessarily mean these are always industrial control systems. It just means that there's a service there that responds back and it has ICS in the text somewhere. So you do have to do some filtering through, but you do find some interesting ICS systems for sure. Now the great thing about Shodan is if I want to get additional information about these, I can just click on the IP address. It's not taking me out to the system. It's taking me to the details that Shodan has about that system. And so you can see it found port 6000, 8887, port 9000, and port 9002 were open on that system. And then you can see that where it found that overbyte ICS TCP server, right, it was running on port 8887. And if I want to find out what that is, right, we can just go to Google. I know I can just type it in the browser there, but there's reasons why we don't like to do that, but that's a whole forensics conversation. Right? And then we can look to see, and it says, oh, yeah, here's Overbuy. It says ICS is a free internet component library. And it's like, oh, okay, well, is it still really related to industrial control security, or is ICS stand for something else? And in this case, it stands for Internet Component Suite, right? So it's not industrial control systems like we're looking for, right? But if we go back and we look at some of these other pages, right? If we go to these actual different websites that are pulled up, then there could be some type of industrial control system there. And so we're going to kind of put a pause on that for just a second because we're going to come back and look at some of those examples from a different method. But I did want to highlight that because, again, I think it stresses the point. In this case, we're doing a lookup for just the term ICS. It's not a tag. It's not where Shodan saying this is an industrial control system. It's just we saw the text ICS in a response from the machine, and it's got picked up in our search, right, in our Shodan search. So again, those are some common search terms that we can look for. Now, you can do, and we talked about, again, SCADA. We also can look at IIoT, which actually can turn up some interesting results. So IIoT is the industrial Internet of Things. So we're actually purposefully taking industrial control systems and connecting them to the power of the cloud, right, or to the internet. So you can think of an example where, let's say, as a very popular example with GE. GE makes these locomotives, for trains, and they want to be able to take sensor data from that locomotive so that they wrap the entire locomotive in sensors so they can take all that data and then they can look at it over time so that way they can proactively address issues. So if they can see that a part is going to wear down using predictive analysis, they can go ahead and they can replace that part ahead of time before it breaks and then causes downtime with the locomotive, or potentially even cause a physical issue, which could also lead to somebody getting hurt. Or passengers could be killed. Right there's real world consequences that could happen. The problem is you can't have a computer large enough or powerful enough sitting on the train to take in all that data and process it. But if I take the data, send it out over the internet, maybe from a train on a satellite connection, send it out to the internet, and then I can use the power of the cloud where I have the large systems that can bring in the data and they can crunch the numbers and do the predictive analytics. So that's the idea of IIoT. So we actually do see the control systems exposed or connected to the internet, but they shouldn't be exposed to the internet. Right? So we shouldn't see these systems pop up in Shodan, but you can still find them. Right? So I mentioned you can see ICS, OT. Again, ICS and OT can be very generic, like the example that we were looking at earlier. Now you can also look at vendor names. So Schneider Electric's an example that we looked at earlier when we looked at that Modicon, which is that programmable logic controller that I have in my home lab. You can see, Rockwell Automation is also another popular uh, popular vendor of control systems and PLCs. I used to work in San Diego right next door to Rockwell, so yeah, I've always been a big fan. And Siemens was actually right down the street as well. But you can start to see if I do Rockwell Automation, which is also related to an older company called Allen Bradley. You can see, oh yeah, this system right here, just on 166.136.164.22, right? It actually found a connection, right? It did the additional query and got the response back from the system and said, "Hey, I am a Rockwell Automation Allen Bradley PLC, and here's my serial number. Here's my internal IP address." So we know their internal network is using a 192.168.100 numbering scheme. And then it also gives us the product name, right? So we could Google this, right, to actually see, well, what type of system is this? And then you can see, I always like to jump to images real quick. And you can see that's what we're looking at. So this PLC that looks just like this, which is sitting in some type of environment, has two IP addresses, more than likely. Or at least it has an internal IP address, right, of 192.168.100.2, and then somehow it gets out to the internet as 166.136.164.22. And Shodan found it and indexed it for us to find. And so that's how one way, right? You can look at another way you can find things like PLCs connected to the internet by looking at these common vendor names, right? Which is what we're looking at there. So you also I could see Allen Bradley was also there. So Allen Bradley got bought by Rockwell. So we saw in that case both of them. Right? Siemens we mentioned is also another large industrial control provider. So those are some great ways to find some really interesting systems, and you can see how they're very talkative, right? Because it's, oh yeah, hi, I'm a PLC, right? Here's my serial number. Here's my internal IP address. Here's my product type, right? I mean, it goes on and on and on. So they give you, if you're an attacker, right? They give you everything you're looking for essentially. to be able to target that system, including the version of the operating system or the firmware that's running on that PLC. So you would know potentially if it has vulnerabilities or not. Now we can also look for things like you can see device type names. So in the example we were just looking at, remember it actually said programmable logic controller. So you can spell it out just like that. Or you can try PLC like kind of using ICS. You can find some things. Might take you a little bit uh, to dig through. There's HMI or Human Management Interface. If you're not familiar, HMI is basically like a little screen that you can use to interact with a control system. It's like if you've ever seen, a digital thermostat like Nest, right? It has a little video screen, and you can see what they call the set point, right? Where your temperature is set, and then if the temperature gets too cold, right, it's able to turn on the heater. If the temperature gets too warm, it can turn off the heater, or if it needs to, it can turn on the air conditioner. So that's an idea of a human management interface. We're actually going to look at some real world examples in just a minute. There's also the idea of DCS, right, which we see in larger environments that are used to control multiple industrial control systems. We can also look at the brand type. So we mentioned earlier, I have that PLC that we saw a screenshot of. That's called a Modicon from Schneider. Siemens has Semantic. There's not Semantic, but Semantic, and so on and so forth. So forth. So there's a lot of different brand types. You can look for specific models as well. So those are some of the examples that we were seeing earlier. So you can look up those models. Of course, there you have to be very specific, but it is a way to find those industrial control systems beyond just using, especially tags, if you don't have that expensive account. One of the other really interesting things I find really fascinating with Shodan is Shodan also indexes services that can be um, that they like to take screenshots of. Meaning, I'll just show you because it probably will help. If you go to, and I'll just type in images.shodan.io, remember, not .com. You can see it actually takes a screenshot anytime it finds a service of interest. So you can see in this case, it actually takes screenshots of, you can see camera feeds, so webcams essentially, and then remote desktop instances, right? Which neither of these are necessarily good. We definitely don't want remote desktop sessions exposed to the internet because somebody could use those to gain access to your system. And you probably don't even think or you're aware of that camera being exposed to the internet. Or sometimes people do set up a camera at home. They want to see it from work, right? So they knowingly expose it to the internet, but they don't think anybody is going to be able to find it. And yet Shodan does, and Shodan will let you go through and find all of these. If I want to narrow it, especially down to just those web servers, I can just type in HTTP. So it takes out all the remote desktop sessions, and then it'll limit to just the webcams that are available over web services, so over HTTP. So you can see there's an airport, there's somebody's junk room, there's a garage, there's it almost looks like a solar farm right down there. So that would be a example of a industrial control environment, because there are systems that control those panels and the electricity that's generated and how it flows and how it's pushed out to the grid. So that's interesting, right? Because what if this camera is connected to the control system network? If it's an asset on the control system network and it's exposed to the internet, and if it's a webcam, it's probably a really easy to break into system. And if I take control over that and it's on the control system network, I have a foothold into that control system network, and I can then use that to take further control of that network. But I find the images fascinating. I can sit there and just flip through pages, all day long, just to see what's actually there. You see some really really neat things. Just kind of a trip around the world in 5 or 10 minutes. So, and so we can see those different aspects. Again, we looked at the remote desktop sessions. Right? Those are dangerous because not only is that system exposed, it's not behind some type of device like a VPN appliance, right? It's exposed directly to the internet. In this case, we can also see they didn't rename the default administrator account. And then we can also see there's 3 users on the account, or the system. So we see Alicio, Dukia, I'm probably butchering the pronunciation, and Ricardo. Right. So all we need is a password for any of those 4 accounts, and boom, we're in. Or what if the system hasn't been updated and it's vulnerable? There's been several well-known vulnerabilities that are very easy to exploit through Metasploit to allow you to gain access to that system. And whether it's on the IT or the OT network, once you have that foothold, right, you can use that to spread to those different types of networks. So having remote desktop exposed to the internet is very dangerous, especially if that machine is on the control system network. Right? We mentioned web cameras. I found these really quick. I always find it really interesting when you find a dashboard with lots of cameras in it. So you can see there's multiple rows with all these different cameras. Looks like they're just watching over like different aspects of freeway somewhere. I didn't get into it too much. And then I thought this was interesting as well because here's a water treatment facility that's exposed, that has a webcam exposed to the internet. It's an example, just like the solar farm, that maybe this camera is standalone, is connected to the internet. It's not connected to the water treatment plant network. And so, you know what? That's okay. But what if it is exposed and it is connected to the water treatment network? In that case, if I take over that camera, right, which is typically just a Windows machine or a Linux machine, if I take control over that camera, then I have that foothold into that control system network. And then I can spread control, right? I can move laterally and take further control over that water treatment facility. Right? So it's a real world concern. And so that's why organizations, right, or if we're pen testing for our clients, we need to make sure they don't have exposed systems, whether it's remote desktop, whether it's webcams, whether it's anything. Right? If it's exposed, we need to understand, oh, yeah, it's a web server and it's meant to be. But what about all those other systems and services and industrial control systems that are exposed that aren't supposed to be, right? That's the beauty of Shodan. It allows us to find those. And here's an example of one of those human management interfaces or those HMIs that I was talking about that's available over a web page, which a lot of these can be exposed just as read only. So it allows you to look and not, you see buttons, but you can try and click them and nothing happens. But what if you find the ones that are interactive? And so it's interesting when you find, like in this case, oh, we have this tank and it stores some type of liquid, and there's a blower, and then you can see the different pumps, right, to be able to move liquid right out of the tank, right, and all the different valves, and I mean it just we don't want anybody sitting here, especially as the chemical drum, right? I don't want anybody sitting there able to make changes, right? It's just, I always find it fascinating when you find control systems through Shodan and you find these interfaces, and basically it's a big error message like fault, and it makes you wonder if somebody actually was screwing around with it from the internet, right? And like in this case, you can see and potentially it looks like, well, the system's off, I guess, at the moment. So, um, but I think it's fascinating when you find these, and you can see them just by going to that images page, limit to HTTP, and then you can flip through, and it doesn't usually take more than maybe 9 or 10 pages at the most to be able to start finding HMIs for industrial control systems. But again, it's another way to find these systems connected and exposed to the internet that they're not supposed to be. Even even if they're just for read-only access, put them at least behind a VPN. So you're not giving attackers a potential foothold on the network. And then the last thing to look at is um, one of the generic uses of Shodan is let's go ahead and run a search for a IP range. So if I know my company has, let's say, this network range of 153.156.222, right, Class C address, or what if that's my client and I'm doing a penetration test for it? The idea is I can go ahead and do a lookup, and this was just one that I picked it at random based off of one of the systems I found, right? But if I go back to the search, I can just do net. Well, let's go back to the normal page. So we can do net and then go back and look at that number. So 153, 156, 222.0/24. So we use the CIDR notation, right, for that class C, and Shodan's going to come back and it's going to give us a list of any of the IP addresses in that range that it found active, right? It can have up to 254. And you can see it actually found 79 different systems in that one range. So let's say this was my client I was doing a pen test for, or a company I was working for. Again, I want to use Shodan to go back through, find all the systems and expose services, and make sure, are these really expected and supposed to be exposed to the internet or not? And if they're not, right, we want to shut them off. We want to firewall them off, or at least put them behind a VPN. So that way attackers that are out on the internet can't get directly to them. Because remember, every service, every application that's exposed to the internet is a potential route for an attacker to get into the network. Or it's just like the attackers, they're driving through your neighborhood looking to see if the garage door is open, or how many doors do you have, how many windows. Right? And then they might go up to the door and see if it's locked or not, or try to see if the window is open or not. So we want to make sure we close all those off. Or if we don't have a door to the house, the attackers can't get in, at least that way. Right? If there's no windows, they can't get in through a window. Right? Disable, right? Turn off all those services and don't have them directly exposed to the internet. So that's a great thing to do when, again, doing a search against your own range or against your clients if you're doing a pen test. But anyways, I just wanted to wrap up with that, and you could use that to potentially find, if you had, let's say, you worked in a control system environment like a power plant or one of those water treatment facilities that we were talking about. You can work with your network services team with IT or telecom to ask them, hey, what public IP ranges do we have? Hopefully they have a complete list, but you can take that list and go to Shodan and run a search and see what services are exposed, and hopefully, at least for the purposes of this conversation, make sure that you don't actually have control systems that are exposed to the internet, because that's one way, again, that attackers, if they find that system, they take control over it, and then they now have that foothold on the control system network, and they can use that to spread further control and take over that facility. They can take over that power plant, that water treatment facility, that subway, that refinery, the open pit mine, and any other industrial control environment. There's serious consequences if they do. Right. So that, in a nutshell, though, is using Shodan to find industrial control systems, and hopefully found that helpful and worth the time. So I appreciate you taking the time to check out the video. If you have any questions, comments, concerns that come up down the road, if you want to reach out and connect on LinkedIn, here's the information where you can find me, or my email address. You can reach me at michael@utilsec.com. It's one of my side email addresses away from my day job. And then you can find me at LinkedIn at Mike Holcomb. So, and I will talk to you then. Thanks again, and take care.